Good evening to one and all. Now welcome back our favorite video channel SGVS. This is B Ramesh Kumar, JL in Mathematics. In previous video we discussed some problems in homogeneous linear system. Now here also we discuss different model in homogeneous system. So in previous video we take the system is 2x plus 3y plus 4z equals 0, minus x plus 2y plus z equals 0, 2x minus 3y minus 6z equals 0. Now we take this type of systems. Here we observe the coefficients of x, y, z are numerical constants. Now here we find the rank of the coefficient matrix and the system has trivial solution depend upon rank equals to number of variables. The system has non-trivial solution which is also depend upon rank of the coefficient matrix is less than number of variables. Now the system has non-trivial solution. Now this type of problems already discussed. So here we discuss the different model. Here we observe solve the system of equations. Now the first equation x plus 2y plus 2 plus k into z equals 0. Similarly, second equation 2x plus 2 plus k into y plus 4z equals to 0. 7x plus 13y plus 18 plus k into z equals to 0. For all values of k. Now solve the system for all values of k. In previous video, solve the system. Here we observe solve the system of equations only. Now here solve the system for all values of k. Now here the coefficients of variables contain some scalars. First of all find the value of the scalar. Now the system has trivial solution or non-trivial solution depend upon the values of the scalars. Now here in this problem the scalar is k. First we find the values of k. Then here we take the determinant of the quotient matrix sum equals to 0. Then simplify this determinant and find the value of k. Now here we take the values of k. Some the system has trivial solution or some values the system has non-trivial solution. So first of all we find determinant of the coefficient of the matrix. Now here the coefficient of the matrix of the given system is here the coefficients 1, 2, 2 plus k, 2, 2 plus k, 4, 7, 13, 18 plus k. For suppose if the system has a non-trivial solution, then rank of A is less than number of variables. Rank of A is less than number of variables. Or determinant A equals to 0. Now depend upon rank of A is less than number of variables, or we take determinant to find determinant of the quotient matrix, that will be equals to 0. Now here first we find the determinant. That A equals to determinant of 1, 2, 2 plus k, 2, 2 plus k, 4, 7, 13, 18 plus k. Now using row transformations, here we apply R2 changes, R2 minus, here multiply with 2 to first row and subtract from second row. Now this will be 0. Similarly multiply with 7 to first row and subtract from third row. This is also 0. Now here R2 minus 2R1. Similarly R3 changes, R3 minus 7R1. Now the determinant is, here the first row does not change. We can apply second row operation, 2 minus 2 into 1, 2 minus 2, it will be 0. Similarly 2 plus k minus 2 into 2, minus 4. So 2 minus 4, this is minus 2. Now here we take k minus 2. Similarly, R2, 4 minus 2 into 2 minus 4. 4 minus 4 cancelled and minus 2 into k minus 2k. So this is second row. Similarly, third row, R3 minus 7R1. This is 0. Here, 13 minus 7 to the 14. 13 minus 14. That will be minus 1. Similarly, 18 plus k minus 18 minus 7 into 2. 14. 18 minus 14. That is 4. Here, this is k minus 7 into k minus 7k. K minus 7k. That is minus 6k. Which is 0. Now, we take the determinant value is 0. Now, here expanding C1 by using call 1 C1, which implies, so here 1 into k, 1 into k minus 2 into 4 minus 6k minus into minus plus into minus minus. So 2k equal to 0. Now it can simplify. Here k into 4, 4k, k into minus 6k, minus 6k square, minus 8 plus 12k. Here also minus 2k equals to 0. Now it can simplify. Minus 6k square. Now the number of k's, 4k plus 12k, 16k, 16 minus 2, 14k. Now the constant is minus 8, which equals 0. Multiply with, so here divide with 2, minus 2, that is 3k square minus 7k minus, plus 4 equals to 0. Now here this equation can be written in factorize. Here 3 4 is 12. 3k square minus 3k minus 4k plus 4 equal to 0. Now here we take 3k common. The remaining value is k minus 1. Minus 4 will be common. K minus 1 equal to 0. Here we write k minus 1 into 3k minus 4 equal to 0, which implies k equals to 1 and 4 by 3. These are the values of k. And here, first of all, we observe if k equals to 1 and 4 by 3, then the determinant equals to 0. That is the first one. We observe this. If k equals to 1, now we take the values k equals to 1 and 4 by 3, the given system has non-trivial solution. So, now we take the first case, case 1. If k is not equal to 1 or k is not equal to 4 by 3, then the determinant is not equal to 0. K is not equals to 1 and k is not equals to 4 by 3, then determinant A is not equals to 0. Now here in this homogeneous system, determinant of A not equal 0, then the system has unique solution, that is the trivial solution. Trivial solution means 0 solution. Therefore, the given system has unique solution, that is trivial solution or 0 solution for the values of are not equals to values of k are not equal to 1 and 4 by 3. Now here also we observe, depending upon rank, now here that A not equal 0, the rank of the quotient matrix is 3. So here rank of A equals to 3. Now which equals to number of unknowns. Here the number of variables or the number of unknowns are equals to 3. Therefore, number of linear independent solutions equals to n minus r, that equals to 3 minus 3, which equals 0. Number of linear independent solutions are 0. Therefore, the solution is x equals to y equals to z equals to 0. This is the case 1. Similarly, we take case 2. Here, now in case 2, we take the value k equals to 1. K equals to 1. Now the quotient matrix is 1, 2, 2 plus k, that means 2 plus 1, that is 3. Here 0, 1 minus 2, that is minus 1, minus 2 into 1, minus 2. Similarly, the third row is 0 minus 1, 4 minus 6 into 1, that is 4 minus 6 equals to minus 2. Now here we observe, we take transformation, row transformation, R3 changes, R3 minus R2, that equals to 1, 2, 3, 0 minus 1 minus 2, 0, 0, 0. Here we observe that which is in echelon form. Which is in echelon form. Therefore, number of non-zero rows equals to 2. Rank of A equals to 2, which is less than number of variables or unknowns. That equals to here the number of variables x, y, z. These are 3. Therefore 3. Therefore 2 is less than 3. Now here in this case the system has a non-trivial solution. So the given system has non-trivial solution. Here number of linear independent solutions equals to n minus r. Here n means 3, r value, rank of quotient matrix is 2, so 1. So here number of linear independent solutions are 1. Now we take equations in echelon form. Here 1 is coefficient of x, 2 is coefficient of y, 3 is coefficient of z. Now the equations are x plus 2y plus 3z equals to 0. Similarly, we take the second equation, minus y minus 2z equals to 0. Now here put z equals to some scalar c1, which implies y equals to minus 2c1. Y equals to minus 2c1. Now we substitute these two values in the first equation. This is equation 1, this is equation 2. Therefore, x equals to minus 2y minus 3z. That equals to minus 2 into minus 2c1 minus 3z. Z value c1, so 3c1. So here that equals to 4c1 minus 3c1, that equals to c1. 2 minus 2 into minus 2, 4 c1 minus 3c1, which equals to c1. Now the solution. The solution is x, y, z equals to, now here x value is c1, y value is minus 2c1, z value is also c1. Now we take common c1, 1 minus 2, 1. So this is the independent solution of the given system. This is case number 2. Therefore, this is the general solution of the given system. Now in case 3, we take the value of k is 4 by 3. So k equals to 4 by 3. The quotient matrix can be reduced to A equals to, here we observe that the first row is 1, 2, 2 plus 4 by 3, 0, 4 by 3 minus 2, here k minus 2, replace k value 4 by 3 minus 2, minus 2 into 4 by 3, minus 8 by 3. Similarly, third row is, which is 0, minus 1, 4 minus 6 into 4 by 3. So 6 into 4 by 3. Here it can simplify. The matrix is 1, 2, 3 to the 6 plus 4, 10 by 3. Here this is 0, 3 to the minus 6 plus 4. Minus 6 plus 4, minus 2 by 3. Here this is minus 8 by 3. This is 0, this is minus 1. Here 3 to the 6. Now 6 is divided by 3, that equals to 2. 2 into 4, 8. 4 minus 8, that is minus 4. Now here we observe the second element of third row can be converted to 0. Now the transformation is, here R3 changes, R3 minus 3 by 2 R1, that equals to, the first two rows does not change. Here this is 0, this is also 0. In this one, R3 means minus 4, minus 3 by 2 into R2 means minus 8 by 3. So here it can simplify, 3 3 cancel, 2 2 ja, 2 4 ja, minus 4 plus 4, this is also 0. Now here R2 changes, R2 by minus 2 by 3, that is 1 2 10 by 3, 0 1, here minus 8 by 3 into minus 3 by 2, 3 3 cancel, 2 1 ja, 2 4 ja, that value is plus 4. So this is 4, this is 0 0 0. Now here we observe that this is in the echelon form, which is in echelon form. Therefore, number of non-zero rows equals to 2. Therefore rank equals to 2, which is also less than number of unknowns, that equals to 3. Here the number of variables are 3. Therefore here we observe 2 is less than 3. Therefore number of independent solutions equals to n minus r. So 3 minus 2 equals to 1. Now we take equations in echelon form matrix. The equations are x plus 2y plus 10 by 3z equals to 0, which is equation 1. Similarly, we take y plus 4z, which is also equals to 0 in equation 2. Now here we take the value of z will be scalar, some C2. Put z equals to C2, which implies y equals to minus 4C2. 4z, that means minus 4C2. Now here we take z equals to C2, then the value of y equals to minus 4z, that equals to minus 4C2. Now here substitute the values of z and y in this equation 1. Now here the x equals to minus 2y minus 10 by 3z, that equals to minus 2 into minus 4C2 minus 10 by 3 into z value is C2. Here it can simplify 8C2 minus 10 by 3 C2, that equals to 3 8 ja 24, 24 minus 10 14 by 3 C2. Therefore the solution is x y z equals to, x means 14 by 3. Here we take common C2 into 14 by 3. Y value is minus 4C2, that means minus 4. Z value directly C2. Now we take common C2. The quotient of C2 is 1. So the solution is 14 by 3 minus 4 and 1. So this is the general solution. This is the general solution of the given system. So this is the case number 3. So here we observe the system contains some scalars. Now solve the system for all values of k. Now here we take the coefficient matrix, and here we observe this system has a non-trivial solution if the rank of A is less than number of variables, depend upon rank. Now we say that this system has non-trivial solution if determinant of coefficient matrix also 0. Now we take determinant equals to 0, then find k values. Now here k has two values, k contains two values, that are 1 and 4 by 3. Now in the first case k is not equals to 1 and 4 by 3, then the determinant is not equal to 0. That means rank of A equals to number of variables. Now the given system has trivial solution. Here the number of independent solutions n minus r, 3 minus 3 equals to 0. Similarly, here we take, in case 2, we take the value of k equals to 1, then substitute the value of k in the given matrix, coefficient matrix. It can simplify using row transformations. Then it can be reduced into echelon form. Here we observe rank of coefficient matrix is less than number of unknowns. Therefore, it has also a non-trivial solution. Therefore, the number of independent solutions equals to n minus r, that equals to n minus r means 3 minus 2 equals to 1. Now, solving the given equations in echelon form, then find the solution. That solution is xyz equals to c1 minus 2c1 c1, that is equals to c1 into 1 minus 2 1. Now this is one linear independent solution in case 2. Similarly, we take the value of k equals to 4 by 3 in case 3. Then find the quotient matrix. It can be reduced to echelon form. Here we observe in that echelon form, here also rank is less than number of unknowns. Here number of independent variables also equals to 1. Now here we take the equations in echelon form and it can simplify. Then the solution is C2 into, C2 is any scalar, C2 into 14 by 3 minus 4, 1. Now this is the general solution. Now here in case 2 and case 3, two independent solutions are contains the given systems. So this is complete solution of the given problem. Thank you.